So anyway, I'll be posting that after class. So today's reason for today was to talk a little bit about what to expect on the final and review for the final. I did want to tell you all that so basically since we left, my postings have been about the construction surveying, and we did have a chance to start construction surveying, but then we kind of moved into this modality. So I started out with some of the construction surveying slides, went all the way through, finishing up with vertical curves on there. And then next we moved on to the surveying equipment. And I would have loved an opportunity to actually have worked surveying equipment with you all, but unfortunately the best I could do was send you some of the video products from either the manufacturer or things that I had produced there. So hopefully you got a chance to look at all those. I'm getting a little feedback from someone there. So if y'all wouldn't mind, maybe if you could mute your mics for now. And that would help a lot, just a little bit, so make it a little bit easier. Thank you all for those of you who are doing that. So next thing, just to kind of let you know about the survey equipment. Those videos that you saw really were structured around the kind of the two pieces of equipment I would have trained you guys with, and that is the TopCon GPS system and the Leica GPS system. Then in addition to that, I did talk a little bit about, or put a video up there about how to use a total station, a Leica total station. Now, bear in mind, I don't know what you guys are going to do when you get out there in the industry and what you may encounter, but these videos really are about any type of equipment. I try to make them not specific to that particular manufacturer. So I just wanted to bear in mind that, I wanted you all to bear in mind that this really is kind of general information, even though I used either TopCon or Leica to kind of demonstrate to you guys. That being said, I'm going to go ahead and I'm going to head into the information for the what I would expect you all to know on the final. Right now, the final is scheduled for, unfortunately, we were the very first final out of the gate, if you remember, and our final is scheduled for Monday, this Monday, the 27th at 8 a.m. My plan is to go ahead and open that up at 8 a.m. and close it at 11. I think we had till 10:20 on the original university schedule, but since we're in this sort of a schedule, I don't know that we have to make that happen. Some of you may have to leave if you're going to another final, but I'm going to leave it open from 8 to 11. Then after that, it will close, and I would expect you guys to, then it's going to self-grade itself, so you should be able to get immediate feedback. If for some reason someone can't make it, because I know there's a lot of you out there working or something like that, please let me know so we can try to set up some alternative time in which we'll be opening, we can get you that exam. That exam is going to be, it's going to be open book, open note, and anything you guys can use to do that. There's just no other way to go around doing that. So that's going to be my plan. Okay, so that being said, I'm going to share with you my screen. For those of you who are aren't able to see the video, I apologize for this, but I will talk to you a little bit about it. I actually did post this also on Blackboard. It's in course information. You can find both of them in there, and I think I even posted it in the modules. And you can see it's called final exam preparation or study guide information. Okay, so I'm going to share this with you. So what I'm going to share with you is no different than what you guys have been using all year, which are these slides for the construction surveying piece of this. So I'm going to just be using those. I've tweaked them a little bit, and I've edited them a little bit since we've been going through the semester. And then at the end of this slide deck, I've included the information about equipment. So you guys are welcome to follow along with me if you'd like to pull that document up. If not, like I said, it is available, and I would recommend you use it as a study guide. So if you have any questions, please stop me along the way. Just unmute your mic and try to jump in there and say, hold it, Mr. Minsick, let's stop and let's go over that again. Okay? I'm going to go ahead and move on in now. So I have decided that the final is not a comprehensive final. It's only going to cover information beginning at construction surveying and to the end of the semester. So unfortunately, it's almost all the time we were doing the online modality or the different modes of delivery. So I just have to say, unfortunately, that's just the best we can do at this time. Next thing I would talk to you a little bit about is what to expect on that. As always with my exams, you know that I do have a terms and definitions piece of that. So these are the important terms and definitions that I would expect you to study and be prepared for during that exam. So I won't spend a whole lot on them and I won't talk about each of them, but it's important to know terminology. I think it's especially important if anybody, I want to make sure, it looks like someone just joined the meeting here. I want to make sure that I admit everybody in. So excuse me for a second as I step aside. Again, Tyler, I think you're just entering the meeting. Welcome. Oh, I see you. I have a Luis. I'm giving you information to access to the meeting. Hopefully, welcome. All right. So getting back to terms and definitions, I'm a firm believer that we sort of have to learn to talk the talk in there. So that's what the reason for the terms and definitions in here. So I do recommend that you study up on the terms and definitions. Okay, then we talked about the purposes of construction surveys. At the time we initially put this out, this was kind of your first experience to this. By now, I think you've gotten a chance to hear the videos and hear a lot of information about that. So I encourage you to make sure you know what the purpose of construction surveys is. We talked about the importance of keeping notes and that, and I do want to reiterate this. I do, in my past experience, has been that really the communication piece is vital to this construction surveying, because this is a high risk part of the business. And because of that, keeping notes is essential. And by that, I mean, making sure you keep notes, making sure you communicate, making sure everybody who is in the field in this is involved in the decision-making process. Or even not the decision-making process as much as just information process, because I have found that that's kind of one of the big faults in this business, is that doesn't happen. So importance of notes is critical. I especially say this because we're also in the time of electronic technology and communication, so we really don't write things down anymore. Maybe we make a note on a phone or in a note somewhere. Just make sure that all that information is constantly shared and keeping everybody informed. Computation of grade stakes and slopes, how to calculate slope. That is something I would expect you all to know. Again, remember, that's just taking the difference in the elevation between the 2 points and dividing it out by the distance expected between. And so again, we did a little bit of calculations on how to calculate slopes. We talked about the laying out, and remember, everything about this set of slides and this information was about how would you use this in a construction surveying environment, and what sort of pieces of data do you need to know. So one of them was offset stakes, and that was how do we set stakes off of a construction site, and that the offset stakes do in fact reflect the location of where the stake would be. Any question? I hear a question out there. Okay, heading on. Offset stakes, just continue to encourage you to look at the slides. The slides talked about how to set offset stakes and some of the information that goes on in offset stakes. Baseline, it talks quite a bit about baseline. So when we talk about baseline, that usually deals with an alignment. We have used the term alignment quite a bit in class, and that's where we take a line as it runs through a project. The biggest example I can use of that would be a roadway. If we were going to construct a roadway, it'd be right down the center line of the roadway maybe, and that would be how we would define the project. And then things would happen either left or right of that alignment. And we would use that alignment by cutting it up into slots, a slice here, a slice there, etc. The common practice is to use 100-foot intervals. So that's where we get the term 1 + 0, 0, 2 + 0, 0, so forth and so on. And that coincides with the construction process. And I just want to make sure everybody understands baseline and stationing, how that works. We went into the different types of, we talked about the different types of markings on the stakes, but more than anything, I want you to understand the different types of construction. Typically, we're going to have we're going to be either excavating, going down to something, or putting fill material in or embankment material where we come up to something. So usually the stakes are going to reflect either what we call a cut or a fill. That's been the common practice. And just knowing that you understand that that's the importance of that. So going on to the next slide talks about fills. There was a little talk about what a blue top was, usually in the construction industry, or just even in the construction surveying business. Typically, if we paint something blue, then we normally mean that you've hit the grade there. And when we set a blue top, that's actually telling us that at the top of that mark, or wherever that blue mark is that is the actual grade of construction that we're expecting. So again, there's some information on that. Then I head into the laying out of a building. Remember the structure. So we talked about two different ways of construction here. We talked about what I like to call infrastructure surveying, which is kind of alignment, roads, bridges, dams, sort of something that we have a linear line. Maybe it's could be railways or power lines or water lines. Then we talk about what I call vertical construction, which would be things like buildings and structures. We did do a little bit on how to lay out a building using the building layout process and offset stakes. And then I went in and talked a little bit about the batter board process. So I encourage you to do that. Gave some examples of how you would set up batter boards and how you would use string lines to help control a project. So again, I think it's important to make sure you sort of know the process. I think if you're familiar with the process, you should be able to answer questions related to those. Staking out of highways. So we'll talk a little bit about highways and some of the main terminology. I talked about some of the things in some of the terms in the textbook. And also these terms were up front and at the beginning of the slideshow. So just this is to reiterate, I would expect you guys to know those. What is a roadway section? A roadway cut, fill, or a transition section? And I think on this next set of slides, I talk about that. To simply define a cut section as a section in which, now I'm reverting back to the roadway section. In a typical roadway section, if we're in a cut section, that would mean that the finished ground roadway would set below the existing ground, meaning that we would have to remove the material to get to that. A fill section obviously is opposite of that, where the finished ground of the roadway would be above that, so therefore we would be filling up to do that. A transition or a mix section would be one in which we would maybe the existing ground will be in some part of it, we'll be cutting it out, some part of it will be filling it. That is very common in the construction industry, especially in the mountains of Colorado. We usually excavate out of the side of the hill and put some of the excavation material out on the downhill side. A very common practice. I hope you understand and be able to recognize that. So those, I would encourage you to study those. Now we get to the slope staking process. I did put out quite a bit of video on slope staking. I also did, there was also a section in these slides. Okay, I will tell you right now, I am not going to hold you responsible for the slope staking process on the final exam. It's somewhat cumbersome, and it really, it's a trial and error process. I thought it was important because I think you guys needed to understand how the process went, but I'm not going to hold you responsible in an exam. One, it's also hard to ask questions about it. And then two, it's also very important that you guys understand the process. Kind of understand the process. But one of the reasons, I'm sorry, I chimed away there for a second. One of the reasons I'm not going to give you questions on it is it's a complicated sort of a process. So I hope you guys keep this information in the future and you remember that. I guess the one thing I do want to tell you about slope stakes is one of the key most important things about slope staking is that stake that we set in the field, that is the place at which the original construction, the original ground and the existing construction come together. That's where you're going to start the project, or in the project, you're either going to start cutting from there or you're going to start filling from there. And that's usually what a slope stake means. Okay, heading on past slope staking and the slope staking procedures, I'm heading into the slides, horizontal curves. Now, this is probably the one that scared you most because we did do a lot of the survey, the mathematics about horizontal curves. Many of you did ask some really good questions, and hopefully I got back with most of you on your questions on some of the assigned work on that. But the homework on that was more about learning how to compute some of the pieces of the horizontal curve. Now, this first slide talks about the difference between circular and spiral curves. I would encourage that you know the difference between circular and spiral curves, but also bearing in mind that most of our learning process centered around just circular curves or simple curves. The biggest thing to remember about the circular curve or the simple curve is that it has one consistent radius throughout all the curve, where a spiral curve is more of what I would use the term parabolic curve, meaning that that the radius is constantly changing. And again, recognizing some of the types of curves, there are some examples of that down there in both spiral and circular. Now I'm heading to the slides on elements of a simple horizontal curve. Now this is very important that you guys recognize what these components are in the curve. As a matter of fact, slide 29 right here, I would venture to say that most of the professional exams, whether it's professional engineering or professional surveying exams, will talk about this piece, this actually configuration when they actually talk about solving for a curve, a horizontal curve. So it would behoove you to know these parts of the curve. So for example, understanding what the delta is, understanding where the PI is and the PC and the PT of a curve. I would recommend that you go back to those slides and make sure you know those pieces. So slide 29 and slide 30 does talk about them and actually does define what they are here. Unfortunately, the sketch just gives you the first initial of what it is. And then, but this slide, especially slide 30, does tell you what those acronyms stand for, or what those initials do stand for. Understanding that is important, and just recognizing that if you're given some pieces of information in a curve, that you recognize what exactly they are. So I put this slide together because of the calculation process, and it's about calculating the horizontal curve. So what do you need to know to calculate the horizontal curve? Now, the difficulty in kind of the method we're in right now is I'm going to give questions that are related to the fact, like calculate a curve and then try to find the answer off of a multiple choice question over here. So I won't be giving you one big intensive curve project where you keep the different elements of it. But you will have to do maybe a calculation or two of an element, or one or two of the elements. So my advice would be get familiar with some of the formulas that we talked about there, because those formulas really will be the ones that will help you calculate these. So my advice on the horizontal curve is to calculate, make sure you know how to calculate the different elements of a horizontal curve. And so on this slide 31 here, you'll see I talk about calculating the elements of the curve. See the formulas handout. Then the next thing would be make sure you know how to calculate the tangent. Make sure you know how to calculate the radius. Make sure you know how to calculate the length. Excuse me. Also, I would ask that you know how to calculate the PC. And I did put in here that the PC is defined as the PI, and you subtract the tangent length from that. That's how you calculate the PC station. Calculating the PT station. The PT station is defined as the PC station plus the length. Again, this was in the information and some of the handouts you all worked on. So I think you should be able to muddle through and actually be able to solve those numbers of those locations in the field. So I encourage you to do that. So that's for horizontal curves. That's going to kind of encompass what I'm going to do on horizontal curves. I know that computations are probably scaring most of you on the exam. I'm going to keep them to a minimum, and they're only going to be worth a certain amount of points. So one of the reasons I'm not going to give you one comprehensive project, I don't want you to have to calculate something and then have to use that number in the next calculation and then end up, if you mess up the first one, you don't mess up the rest. I'm going to try to make it so there's only like a question about different pieces or components of that. So I would recommend that when you're ready to take the exam that you have a calculator ready. Make sure it's a calculator you know how to use. Make sure you have your formula sheet, because there is a time on the test. So it's going to be important that you have enough time to get it done. So the horizontal curve is mainly the part where I'm going to do where I'm recommending that you kind of know how to do at least a few computations. Okay, now we get to vertical curves. There was a slide or a video series on, I think it was just one video, not two, might have been two, and where we talked about vertical curves, or where I talked about vertical curves. Vertical curves are an important part. Now, as opposed to horizontal curves, a horizontal curve, think of the plan view, bird's eye view looking straight down. A vertical curve deals with the elevation differential and moving from one grade percentage into another. While it's very important in the industry, I am not going to hold you responsible for it on the final exam. So I don't want you to have to spend your time studying for that on the final exam or knowing that. So more than anything, it's just maybe understanding the awareness of what a vertical curve is, but I don't expect you to actually be able to calculate any of the components of a vertical curve. So I will tell you, those of you who are CET students, you will be getting this again later on in your classes. There is a class in highway highway surveying, or I'm sorry, highway construction and highway design, and you will get a chance to talk quite a bit about that in those. Actually, you have a couple of classes about that. So I'll go ahead and slip through the vertical curve sort of process here. So that kind of talks about what I would expect you guys to know in the construction surveying piece. The next thing I would like to do, excuse me for a second, I have a phone call coming in here. And thank you. So that concludes what I would expect to do on the horizontal curves and construction surveying. So I would expect you to kind of study that. Now, so I guess before I go on, this might be a good time to ask if there are any questions. Are there any questions at this time?
And these are just the construction slides you put on the Blackboard earlier?
Okay, so this is kind of an edit of those construction slides, and I did post this set, which is those slides with some stuff added to it and maybe some stuff taken out of it. And I posted it just last night, so you should be able to find it both in the course modules as well as the course information. And I think I have in the title, there's something about final exam study guide or something like that. I put it in two formats. One is a PowerPoint presentation. The other one is just a text version, like a PDF version, in case some of you don't have the ability to look at the graphics on there. So I put it in both of those formats for you guys to use as a study. Also, bear in mind, you guys can use these for the exam because it is going to be open book, open note. So I encourage you to go ahead and use this information. Anything else? Okay, so
to the final, how many questions are there going to be?
So $1 million question. Jacob, I'm creating the final as we speak. So you're talking to someone for 32 years. I've had my exam sort of built and been able to tweak and do what I want with my exam. And this the first year I'm not going to give it in a written hand format. So I'm in the process of seeing what sort of slides, what sort of questions adapt themselves really well to the Blackboard question and answer period question. I would expect, if you guys to following through, I wouldn't expect you to take you more than an hour to get through them. I would recommend that, of course, you have your calculator ready and some scratch paper, and you're able to go ahead and do it. The one thing I do want to reiterate is that it is going to be timed. So it's going to be between 8 and 11 that you guys can take the exam. Then it'll go away and you won't be able to access it again. So answering how many questions, I don't know. And again, if there's some calculations on there, I'm going to take into consideration. It's going to take a little bit longer to do those. So I'm hoping that you can get instant feedback and it can grade itself automatically. So there's probably going to be not very many essay type questions. Okay, so anything else? Okay, I have the larger version of Zoom. So I think that our meeting should go on long enough and past the time period. What that means is, for those of you who haven't done Zoom before, you only have a certain amount of time with your free license for Zoom. But if you pay for the updated version, you get a little bit longer time. I have the updated version, so we should be able to go on. If for some reason you guys get dropped out of this meeting, my advice is just to go ahead and put that code back in, go into Zoom, put that code back in, and then click it on, and I should see you come up on the screen asking for permission to get into the meeting. And I'll get you in there. But I think we should be good, but I just wanted to let everybody know. Okay, any other questions? What I'd like to do now then is go ahead and head on into the equipment portion of the class. This is the one I feel kind of the most bad about because of our situation, is we really didn't get our chance to feel and touch and hold and squeeze some of the equipment and do some work. So I'm going to throw this out there for you guys. Unless the university gets rid of me, I expect to be around for a few years there and always be there. I expect to be the surveying teacher for a while, at least of surveying too. So I'm going to suggest that if any of you after this class want to come back and still actually have a chance to use the equipment and do something with me, I encourage you to jump into next year's class with me, and you could go into some of the field projects. You don't have to sign up for the class again or anything. I just give you a chance to actually do the hands-on type of this operation. Or if any of you would just like to get a chance to do it as a learning tool, we can do that when we get back to our traditional way of classroom delivery. So that's open and offer to all of you. As long as I'm still the instructor there, I'm willing to do that for you all. So I thank you for that. And I thank you for being able to adapt with me this year to do it this way. And I apologize for not being able to get you a chance to actually use the equipment. Okay, so the slides that I gave you on the TopCon Hyperlight system, I talked about two major pieces of equipment here. One, the GPS equipment, and one, the handheld controller. Then the videos that I did actually showed you how to set them up. I think the videos actually dealt with the Leica system, where my lecture system here talked a little bit about the TopCon system. Again, bearing in mind that the process is the same with both units. What's different in them is maybe some of the intricacies in the software, but for the most part, the equipment works almost very much similar. So I'm going to hit the high spots, and hopefully you guys got a chance to go through those videos. I think the last video had, the very last video had 5 questions at the end of it. I just want to make sure that everybody did go through all the videos and answer those 5 questions, because I'm seeing those 5 questions populate in the grade book. And as of last look, not everybody had done those yet. So I'm encouraging you guys to go back out and do those 5 questions. They're at the end of the module series on equipment. They're only worth, I think, 15 points, but it is important that I know that everybody's recognizing them. Okay, little bit about how GPS works. Again, remember we talked mainly, and we're talking mainly about an RTK system. By the way, RTK stands for real-time kinematic, which was one of the questions on that exam. What is RTK, or what is something that gives you instantaneous results? And those instantaneous results really come from an RTK system. The term stands for real-time kinematic. What does that mean? That means that the GPS is getting a result, and it's getting an answer based upon many factors, the factors being that it's tracking satellites. Satellites are finding its location. It's using the rod height that you input into the instrument to tell it what the rod height is, and therefore it's finding the position of a point on the ground. That point on the ground is a coordinate. We've been doing coordinates all semester. That's point number, northing, easting, elevation. Now, that coordinate may be in different formats. Could have been metric, could have been English, could have been US foot, could have been all sorts of things. It could have been latitudes and longitudes. It depends. The beauty about the software is it'll filter it for whatever way you want the data. We've been talking mainly about northing, easting, elevations. If you want to put a point number and a description on it, that's up to you to do, but you can do that. Those are the kind of data that we get with an RTK system. The difference with an RTK system, what makes it accurate, is that just a GPS position isn't good enough. A GPS position has to have some of the errors filtered out of it. And by that, it means there has to be a correction factor applied to it. That correction factor is always changing. So what happens is we have to broadcast that correction factor out. So RTK systems have a radio on them also, and that radio intercepts the correction factor. GPS finds out where your location is. The GPS takes that location, corrects it by that correction factor, gives you a position in the field in real time or instantaneous. And that is the process for GPS and what's called the RTK system. So here's some of the things that I would suggest you know in GPS equipment. How do you set up the base and why? And of course, I just told you a little bit about the base. You set it up over a known point, and you make sure and measure the difference, the height difference from the ground to wherever the GPS unit is, put that information in. And the reason you set that up is because it will then take the radio within it and it'll broadcast out the correction factor. Why do we set up a rover and how? Rover is simply one that usually sets on a pole, doesn't necessarily have to set on the top of a pole, could set on a vehicle, you could hold it, but the pole allows us accuracy. We know the distance between the GPS unit and the ground. You put that in the instrument, and then anywhere you navigate around and balance up that pole, you'll be able to get position of a point on the ground. RTK, real-time kinematic. We just talked about that. Static post-processed means that's the opposite of RTK, meaning that instead of being real-time and instantaneous, in static positioning, and we didn't spend much time on this, and I just wanted to kind of bring it to you guys' attention. Static process means that we take all of the GPS information and we collect it in a computer, then we take it home and we process it. And it's called post-processing because it takes place after the fact, and then it has to compute the answer and then come back with the result. We usually only use static surveying when we're trying to do like some major control points or something like that. And that is something that does require software and computer computations. Most of what I would expect you guys to use is an RTK system. The data collector. What is the data collector? The data collector that you saw, we talked in the first set of slides, the FC100 or the FC250. That was the TopCon one, and then the Leica system had the Leica Vivas. Those data collectors, they're nothing more than handheld computers. The reason for the handheld computers, though, is it collects the data and it's able to communicate with the surveying equipment, and then you're able to process your data. So you can do coordinate geometry, you can calculate northings, eastings, elevations, etc. That's what the data collector is. So it's taking a computer in the field. The reason we try to keep one controller is it can talk to either whether it's a total station or a GPS unit, and your file format and your computations and everything are done inside that instrument. You take it with you all the time, or inside that handheld computer. That's what the data collector is, or the data recorder. They all run similar. So it doesn't make a difference if you're using TopCon, Leica, Trimble, or anyone out there in the world. They all sort of run the same. Coordinates, we talked a lot about a coordinate. Understand what a coordinate is. Plane versus geodetic surveying, and I think this is very important. What is plane versus geodetic? That's the difference of plane means we kind of shrink everything down to one flat plane. And by that I would mean we would have our northing and our easting grid, and then we would have, for the third dimension, perpendicular to that, either a height above or below that grid. So that's how we get the 3D. But the 3D in that situation is flat planes, either in the horizontal or vertical direction. Now, geodetic means there's some curvature of the earth, like we would have on the Earth's surface. That means there's a different correction for the curvature of the earth that has to be considered so that we can convert that circular or that spherical to grid. That's the difference between plane versus geodetic. And I'm going to head down here to some slides. This is the last slide in the slide deck. This demonstrates that very well, because you can see here is the grid, and then here is the Earth's surface. So again, that really is the difference. When GPS works, it works on the Earth's surface, works in latitude, longitude, which is spherical, and then it mathematically inside the software computes it to grid. And that's the coordinate system that we use all the time, is the grid. So let me go back here a few slides to where I was. So my kind of wrap up of GPS. How do you get good at it? Just good practice. Make sure your data is reliable. How do you get reliable data? Multiple times. Just make sure you do it all the time. Keep navigating back to points. Make sure you get the same results and answers. I threw that GNSS out there because that was one of the questions on the 5 questions. What was GNSS stand for? And that does stand for Global Navigation Satellite Systems. What does GPS stand for too? I thought it was important that you know the definition of that, which is Global Positioning Systems. Okay, that was a lot of stuff. I apologize for that, but I think it's pretty straightforward. Any questions before I kind of talk about total stations and wrap this up? Okay, I'm not hearing any out there. Hopefully you're all still awake. Total station. Most of you guys, if you've taken surveying 1, you had a chance to do the total station. So I didn't spend a lot of time on the total station, but I did want to just reiterate a little bit about the total station. What is the total station? That's one instrument that does electronic distance measuring, electronic digital theodolite or angular measurement, and it has a built-in computer. That's what a surveying in a total station is. That was one of the questions on the 5 that you talked about. And really the total station's purpose is to measure angles on those horizontal grids and then come up and help you use trigonometry to calculate the coordinate geometry within there. So we're going to use angles and distances to calculate that. The total station is the instrument that helps you do that. Key thing, I guess, about total station measure, if you're using the total station to help you get elevation data, which is the 3rd dimension, you need to make sure you know the height of the instrument, which is the height from the ground to the top of the instrument or where the instrument takes measurements. That's also the same thing for the GPS. If you mess that up, I almost used the word screw up, so I apologize for that. But if you screw up the measurement of that, that will cause an error in your elevation differential. That was also part of the questions on the 5 questions. Again, the next one is the data collector. And that data collector is the same data collector I talked about in the last set of slides, which is, that's the controller that communicates with the total station, and it's able to collect that data. The beauty about data collectors is they're usually able to migrate between the total station and the GPS. And the file format stays in there, and it understands that it's communicating with one or the other to do the computations. Heading on to the process for using total station, it's usually going to take 3 points or 2 intersecting lines. And what you'll be able to do is set up over 1 point, backside another, and turn to the other. So it's a backside instrument at foresight process. That's the standard practice. We usually have something on the end, whether it be a rod or a reflector on the end of where we're going with the foresight, so that we can do the measurements to do it. And the measurements are either done by some electronics distance measuring method. And it simply uses triangulation or simple trigonometry to calculate the coordinates that come along with it. So that's what a total station instrument is. Any questions on that? Okay, great. So now the next thing is a coordinate system, just sort of understanding what the coordinate systems are. For the most part, I just want you guys to remember, and this is kind of not so much for the exam, but as we move out of this class, you guys are going to be working with coordinates the rest of your lives in this field. And basically that means that's the position of a point. And I like to say northing, easting elevation, or latitude, longitude, and ellipsoidal height, something so that you can define that point on whether it be a grid, whether it be a spherical grid or a rectangular grid. And that's simply what a coordinate system is. So I just want you to make sure there can be an assumed coordinate system or anything, but it's a coordinate system which you can work in. And it's either way, if it's national, then you have to tie to a national system. If you're doing your own, it's something you set up on your own. So just encourage you guys to know coordinate systems. Not so much for, well, for the exam that you understand at least the process, and but for the future of your surveying careers, it's very important. And that being said, this is the localization process, or the last slide again, kind of talks about that difference between geodetic and grid, or plane and geodetic, or grid and ground. Okay, so that ends my presentation. So I'm going to stop this share with you all. I'm going to go back to the slide, go back to the presentation. I just want to tell you all I've enjoyed this year. It's been a totally different world for this old dog, and I appreciate you guys all adapting as best as you can through this, and my class as well as others. I know it's been difficult, and if for some reason you guys are just having some struggling with this, please let me know, chime in, give me an email, drop me an email, tell me what's wrong, what I can do to help you along the way. It's not easy. I get it, but we're adapting, and I think we're doing pretty well. Please get on there, onto Blackboard. Make sure you're looking at the videos. Make sure you're doing all of that. If for some reason something goes wrong during the exam, email me after that exam and we'll figure it out. Aside from that, I'm going to leave it open to questions. Are you all still out there?
Yeah.
Okay, Cody.
Yeah.
So you're still out there. Any other questions?
This will be
There, but no
Monday
questions.
morning.
I'm sorry. Go ahead, Cody. Catch that again.
This will start Monday morning at 8 a.m.
Yes, Monday. That's the time. Was the scheduled time within the university's guidelines that were published beginning. So that's the time I'm just using, because I know some of you are taking finals, also finals at different times. So I wanted to make sure we stuck to the schedule.
Okay.
So 8 to 11, and it'll be open during that time. So, I mean, if you don't get in there at 8 exactly and you get in there at 8:10, I don't think it's going to be a problem. It's just going to be open between the 8 and 11 time. It is going to be open book, open note too. So I'm a realist. I realize that I can't keep you guys from looking at that stuff. So you might as well use it to your advantage. Questions? Can I hear from a few others out there that you're still out there?
I have a question.
There
Yes,
yet.
sir.
I'm sorry.
Go right ahead. Hi, Luis.
Yeah, do we have to finish the test before 11, or can we log in at like 10:30, and as long as we log in before 11, we can still know on 27?
Oh, okay, so that's a good question. So Luis, I guess if you're going to have a situation that's different, because I'm not sure where in the world you guys all are. So if you have like a different time and you're not able to use that time frame, why don't you let me know? Send me an email, and then I can do it otherwise. Because here's what's going to happen: I'm just going to tell Blackboard to open it at 8 and close it at 11.
Okay.
And if you need something different, then I'm going to have to work separately with you guys on that. So
Okay,
just let me know an email and I can do it that way.
Okay, thank you.
You bet. Anyone else? Let's see, I have some chat questions here. Let me see. One was, what is the answer for the end of the project question on question 5 curve? So whoever answered that, asked that was a great question. I think that was Jared who asked me that question, and I thank you for that, Jared. You and I were getting a different answer for that, so I have to go back and see what that is, and I'll post that for you. So I'm going to make a note to myself to see what that is. I don't remember offhand. Okay, Colton threw up there 21 plus 40, 63 was what he got. So thanks, Colton. We'll see if that's what I got too. So basically the big deal in calculating that was you began the project at the very, whatever the beginning station was, the beginning of the project, which in that one I think was 11 plus 00. What you had to do was add the overall length of the first one to the first PI and go back the tangent length to get the PC. Once you got the PC, you had to add the length of the curve to get the PT. Had to go back to the next tangent length, subtract off, or I mean the next long length of the leg, and then you had to subtract off the tangent for the first curve, and then add that, whatever you got for that result, to the PT station of curve number 1, and that gave you the PI station of curve number 2. Then what you had to do is subtract the tangent length to get to the PC station of curve number 2, add the length of curve number 2 to get to the PT station for curve number 2. And then you finished up by taking that that third leg, subtracting the tangent length off of it, and then adding that distance to your PT length to get to the end of the project. That was the process. I think most of you did that. So thank you for doing that. I know that's complicated, and it's one of those things that the more you do it, the better you'll get at it. But I think for the most part, you guys did a really good job of kind of understanding it. So don't worry if you didn't get it, but I think most of you got the concept. Other questions? Let's see, what else? Let's see. And I'll look up what I got for the answer and I'll publish it out there for you guys.
Professor, for the quiz that we did, there were some questions there that had, the questions were kind of contradicting a little bit, and it could have been either way. Or do we need to watch out for that on the final? Are they going to kind of be tricky questions and worded weird?
So first of all, I have to say, I apologize for that, Jacob. If they were, they're not intended to be tricky, but sometimes they are, and I can see that. So I apologize for that. I'm going to try to avoid that. One of the hard parts about making multiple choice questions from a teacher standpoint is trying to make something that sounds like it's kind of right, but not. And in doing that, so there are going to be, majority of the questions are going to be multiple choice though. So yeah, I would look in your information to make sure that it's exact, because I'm going to try to make the questions succinct, if that helps.
All right, perfect. Thank you.
Kimberly, I saw you poke up there for a second. Did you have something? I'm sorry.
Yeah, hi. I just wondered, for when we're calculating for the final, if we're like on the right track but we get the wrong answer, we won't get partial credit. You'll just have to mark it off with whatever choice we choose.
Yeah, unfortunately, that's the hard part about multiple choice. And I do apologize for that. I guess one of the things that might be is if you guys found you were uncomfortable about something like that, try to email me after. This process is going to be strange. Normally I would take into consideration that. So here's what I'm going to try to do. I'm trying to limit the questions so that, as I said, one answer doesn't go into the next one, which makes both of them wrong. For example, so it would be like calculate the PI station, calculate the PC station given this data. So there won't be like calculate the PI station, then use that to calculate the PC station. I won't do that to you. I'll make sure and give you the data so that it's only one question. And then the points, the point allotment for the exams, I won't make it worth like 40 points where it's going to be detrimental to your grade. Just a few points per one.
Okay.
Try to be fair on that, because I do appreciate that. And that's a point well taken. I appreciate you telling me that too. Thank you.
Thank you.
Anyone else? So everyone, before we wrap up, I want to once again thank you for this time. If some people aren't on today and not everybody logged in today, and I'm sure not everybody has the luxury of being able to use this process, I'm going to ask that you get, if you're still in contact with them, reach out and try to help them a little bit. I am recording this, so I hope to publish this out there so it'll be able to, you'll be able to see it again. And I'll hang it out there on Blackboard. Biggest thing, I just want to thank you all for the semester. This has been a crazy year. I tried to be as fair as I could in the grading system, and hopefully, I do believe that most of you are doing within the grade process of passing and getting to where you want to be. Now, let me reiterate one thing that did happen this year and came out of the provost's office. And I did send this out in one of my, I think it was an announcement earlier in the semester, when we moved to this earlier in the online stuff. And that was that students do have the option to take an S or an I. So once you see your grades, which will be posted, I think at the end of next week, or at the beginning, or I think it's a week from Monday that they're to be posted. Once you see the postings of those grades, you guys as students have the option to say, ooh, I can take an S or an I. And if you didn't like the grade, the letter grade, you could take the letter grade. If not the letter grade, you could take an S or a U, I'm sorry. And the S being satisfactory, the U being unsatisfactory. Basically, the threshold for what's an S and what's a U is anything that's a D or less is a U. Anything that's an S or anything from an A through a C is an S. So why would this affect some of you? Let's say you had a GPA that you wanted to maintain a 4.0 GPA and you were going to get a B. That might mess your 4.0 GPA. You could choose to take the S, which would give you satisfactory completion of the course, get you credit for the course toward your degree, but not compute into your GPA. Be careful if you choose to use the U. If you had a D and you use the U, then you don't get credit for the class. That's the big threshold right there, is that anyone gets an S, they get credit for the class. Anyone who gets a U doesn't. That would mean you'd have to retake the class. So those are the provost rules. I'm sorry, say that again.
No, I'm sorry. Would it be relevant to even get that for our engineering classes? Like to say, like if a company were to look at our like grades or something like that? Because like say if you specialize in, you're going to be a surveyor and they want to see how you did.
I think that's a really good question, Kimberly. And so this has been, I've been a professor for 32 years, so I'm pretty familiar with what employers want. As many of you know, I know employers very well. It's been my opinion and my findings that employers don't usually look at your transcript. They look at whether you passed, but they don't look at your transcript. But that's not saying that all of them don't, but most of them don't look at that. Now, grad school and things like that, yeah, absolutely they will. But in this situation or this semester, this is only for this semester, and the provost would not allow this in future years. It just because of the way we made the transition over, and some people are having technology problems. So it's a chance for you to kind of do that. But it would be, that's why he gave you guys the option to choose that.
Okay.
Okay. Any other questions?
Yeah, I have a question.
Yes, sir.
So if you take the U, so you have to retake the class, but that they don't take. I say this for your GPA. They don't take this class into account when they when they do your GPA rating or whatever. You know what I'm trying to say?
Yes, absolutely. And that's a very good question, Luis. So let's say, for example, you guys might have been either like on a scholarship or a grant or something like that that required a GPA requirement. And let's say that, let's say that GPA was, you had to maintain a 3.5 to keep your scholarship, for example. Then all of a sudden you get a B, which is a 3.0, which isn't bad or wrong or anything. It just says that's going to cause my GPA to go down. It might behoove you to just take the S. And then we do it. Or if you're going to fail a class, and unfortunately there are some students in this situation just because of the transition and everything that they're up against an F. And especially if the instructors haven't heard from them, they're probably going to be getting in some sort of like a grade of that effect. If they choose to do that F, then they would get a failing grade, which would hurt their GPA or hurt maybe their even financial allotment. So at that time, you just take the S or the U, and I think the explanation for this year, if any of those agencies ask about that, is this was a unique year, and this was we're not the only school that did this, by the way. CSU Fort Collins did it, and I think CU Boulder did it also. So it's out there. It's and it is an option for you guys to take advantage of, but I think it's up for you guys. And I want you to make sure, because you got a letter from the provost or provost office, I think, or from the university, might even been from the president, and see what it is for you guys to make sure if you want to exercise that, it shows you how to do that on that email. That did not come to me, that came to you guys. So make sure you look that up.
Let's.
Anything else? Well, hopefully you all learned something about surveying, and I love doing this, and I'm disappointed that we don't get you. I'm disappointed that you guys don't get to see my bright, shiny face at 8 o'clock every morning, which most of you did this year. So good or bad, you got to see it at the end here. So thank you for chiming in. But hopefully you guys got something out of this. Please fill out your all of your forms and your information, register for next semester. Also do your evaluations of the classes. It helps us all get better at what we do. And if you just enjoyed the class, also let us know too, because that also helps us. Makes the professors feel a little warm and fuzzy. But anyway, questions? I'm not
Do we
here.
have to schedule an appointment to register for next semester?
So good question. There has been a lift. They lifted the registration requirement for next semester, so you don't have to have the instructor check off, so you can register. So all of you can add classes now.
Okay.
So if you knew what you wanted, but if you guys need my advice or opinion, and it doesn't have to be me, it could be Dr. Islam or Mr. Sparks or Dr. Al Sharif, you can ask them too to help you out with that, or me. I'm always available. I just got to tell you guys, I've just been swamped with emails and things like that, and trying to keep up with things along the way. And I'm not the greatest at email response anyway, but I've been doing it just constant. So if I missed out on you, please send me something, say urgent, Mr. Minczyk, give me help here, and I will help you guys advise.
Are you able to check off for the higher level classes? Like when I go get like the heavy highway cost class, it says I need like an instructor.
Ooh.
So it won't let me do that.
I think that Sparks has to raise that because Sparks is the instructor of that. Unless it's online.
Well, yeah, because I'm doing the one with him, but I had got like a sign, like an email and stuff from him, and I sent it to my advisor, but she said that the chair needs to sign it off.
Okay.
So, I don't know how that works online now since I don't see you till fall.
Okay, so Kimberly, send me an email to that effect.
Okay.
And what I'll do is we'll chase that. We'll chase that.
Awesome.
See what's
Thank
going
you.
on with that. Okay. Thank you.
Thank you.
Anything else? Well, it's been great to chat with some of you. I hope you guys are staying safe. And yeah, I don't know where this world is going to go, but we just have to be safe. And the beauty about what this has done for us, it's kept us all from getting sick, at least being in the exposure that a school setting does do. So it's worth it there, but it has been hard. So I appreciate your patience in this. That being said, I'm probably going to bring the meeting to a close. And thank you all for a good semester. Please feel free to contact me again via email should you have any questions. Anything else before I go for the good of the cause?
Thank you, Professor.
Okay. Thank you all and have a good one.
Thanks, you do.
See ya.
End the meeting now. I like the Super Bowl 50, whoever sent that.
Yes, sir.
All right. We'll see you all and have a good one. And see you all chiming in at 8 o'clock Monday morning. Okay. I'm going to stop the recording.